technical discussion. And I'm going to go to this sketchpad here, and we'll do create. So let's just draw this out. Effective technical discussions. So one of the key issues with effective technical discussion is that is it repeatable, right? Is one big question, and this is a real problem that I want students to solve when they're in discussion forums. Is can someone exactly do what you showed in a forum? If they can't, then it's not repeatable. And even with Jupyter Notebook, it's not 100% repeatable. And I'm going to actually demo a bunch of techniques that will show you how to do this. Another one is does it have video, maybe audio? Does it have code samples? And maybe even like an execution environment associated with it. These are all examples of things that can make technical discussions much more powerful. Images, and then another component of effective technical discussion is that you're learning yourself. So when you teach people the material, it actually the studies around this show that you're learning at the same time. And so you really want to have a distributed computing type system where all of the nodes are connecting to each other, and basically you're all learning from each other at the same time you're teaching, and it's reinforcing. It's basically a feedback loop. And so some of the effective technical discussion tools that I like to use, one is Colab, and we'll go into that. Another is GitHub, and we'll also go into that real quick. And then another one is Gist. And I would say those are probably three of the bigger ones. And then Jupyter to a lesser degree, and then also Docker. And so what's neat about Docker, and especially Docker files, is that you can check in a Docker file and then someone can execute your code in your project without having to necessarily ask you a question. And so I think this is one of the key questions in the repeatability aspect is there a human, right? Is the human not needed? If the human is needed, then that's not repeatable. If somebody has to ask you a question about how it works, then it's not completely repeatable, reproducible. So let's go ahead and let me show you kind of from the ground zero how to do this effectively. So step one is I would go to a GitHub account here and create a new repo. And in fact, let's call this repo effective technical discussions. So we'll say effective technical discussions. There we go. And say this is a sample repo for effective technical discussions. All right. And I would probably just add some intro stuff here, initialize the Readme file here, and also add a gitignore that has Python. So in case I needed to check some Python code in here, it won't make cruft and things like that. There we go. So we're creating this repo. And next up, let me show you a couple things that are useful. So one trick that oftentimes people are struggling with is they need to add a screenshot to the README, and they're like, hey, how do I do this? This is really complicated. Well, let me show you a little hack here. If you click on issues and you say new issue, this is a hack that I like to use. Is say images, and then I can actually just take a screenshot of something. So let's say that I want to take a screenshot of, in fact, actually, here we go. Here's the book I wrote. I'll just take this book here. I'll throw it in like this, and I'll just call this Cloud Computing for Data. You can just drag any image inside there, screenshots, whatever you want to add. We'll just call this Cloud Book. There we go. And once I've got this book in there, next I can go back to this and I can just throw it inside. And what's neat about this is that it automatically puts the image inside of there exactly in a markdown format. So I could say, this is a good book. And then maybe I would say references right here, right? So this style is a really good style for people because they can look at the raw markdown file. I can commit this change and I can put documentation inside of there, right? So this is the image hack trick. The other thing that's powerful about this is that you also can put in code sample snippets. So let's say I wanted to say, to a friend, I want to show a friend how to write a Python function. I could say here, how to write a Python function, and you could go through here, Python def hello, and then I can write a function where it's at least syntax highlighted, so that it's much higher probability that they can reproduce it. And so we'll say, hi, or something like this, and then do the triple quote. So this is a great style because then I'm giving people rich documentation that has code sampling, highlighting, and then also images that would show through. And in fact, this repo, one of these repos here, like this would be a perfect example, right? Where I have links to locus and links of it plus a video and also code that exactly shows someone what to do. So this would be, again, an effective technical discussion. We could make it even more fancy. We could also use something called gist. And so sometimes this is nice as well, is if I want to share something in a chat forum and just say like chat message, right? And I want to share something with some other students or coworkers. What I could do is just say, def hello as well here. And then it recognizes that it's Python because it's .py. And then this is much richer, again, than just me blindly, putting something in like a Slack channel without formatting or something. It could get confusing. And so then I also could link this in, and I could say, maybe here's how to write a Python function, and I could say, this is the exact gist for you, right? And then I could put a link into it, and then I could even put in, how to code. There we go. So pretty just between these techniques, I think this is really helpful. And I've noticed a lot of people don't know these techniques, but just in doing technical weekly discussions, really, really powerful. But we can make it even better. And the next thing that I'm going to show you is Colab. And this is probably the ultimate gun for, or the ultimate weapon for doing technical discussions. If I go here, I can go to New Notebook. And a few things to point out about Colab notebooks. One of them is you can get a pro version like I have. And what that gives you is, if I go to connect here, is it gives you actually access to a very powerful NVIDIA GPU. And in fact, I have a lot of RAM in this. I have 12 gigs of RAM. And also I think I get like a dual core machine as well. And so let's say I want to do some GPU based coding. I could do it in here and then share it. Or if even I want to do something really simple, let's just make this really simple. And we'll say hello here, go like this. And then I'll add some text boxes here. And I'll say, I am explaining to people how to code. All right. And then next up, what I'll do is I'll just say hello right here, and I'll return hi. There we go. And then I can actually execute this, and I can say hello. And now people can actually exactly do what I'm showing and actually connect to it. Now it gets even better. Now I could just share this. I could just give this link to somebody, or I think this is the ultimate way is I just save this into GitHub. So I'm going to go to GitHub. I'm going to hook it up into my account that I just created, which is repository, which is effective technical discussion. So let's go through here. We'll go to effective technical discussion. There we go. And then I say, okay. And what's awesome about this is that anybody can now get access to this, right? And then they can get this link and click on it and exactly line by line. So this is probably the ultimate effective technical discussion, is that I can actually go through here and click on this link. Now, that leads me into, so this is a good place to stop for this particular topic. And then we'll circle back around to this, but I'm going to go into the next topic, which is effective async technical project management. And let's just briefly talk about this and why it's related to machine learning and cloud computing. So a key problem still in society is the fact that people have problems getting things done. And so one way to think about this is to have effective technical management. So what does that mean? And this is something that I think is really a problem, at least in the United States for sure, is that we don't always have success when we're building software. And one of the reasons why is that we're focused too much on fake things. And so a ticket system in a way is actually like a fiction. It's like a fiction book, but then the demo is more like reality. And so what I would say is demo is greater than ticket. So if every Monday, if you're working in a software company or you're working on a team and on some kind of a project, I would do a weekly demo on a Monday. It doesn't have to be Monday, it could be Friday, but let's just say it's on a Monday. And what you should do is just do like a 30-second demo of what it is you're working on and put it into a discussion channel or show it via Zoom or whatever. And what this solves a few different things. One is that it is the truth of where you're at, right? Where a ticket, someone could say milestone 1. What does that mean? In fact, that means nothing. Milestone 1 could mean someone's just making something up. The ticket can be very helpful, but it means nothing without actually seeing what it is that someone built. And I've actually seen companies that were worth hundreds of millions of dollars fail because they didn't do this, is they were focused on the tickets. And there's another way to put this, which is that this is called fake Agile. And so fake Agile is when you're pretending that you're getting stuff done, but you're not getting stuff done. You can't fake a demo. Either the code works or it doesn't work. And so then each week you should incrementally get better, right? So that's the thing about a demo is incrementally get better. And in fact, there's a word for this, and the word for this is Kaizen. And so Kaizen, in fact, comes from Japanese, and in Japanese, it's a one-to-one. It means improvement. And in fact, this is how in the culture, the automobile culture of Japan, they've been so successful, is that constantly looking at things on a daily basis, weekly basis, is it better, right? And that's what a demo is that's Kaizen. It's I demo, I see where I'm at, and then it's either better or it's not. And so when you're building things in the cloud in particular, and we'll get into this, in fact, that's the next thing we're going to get into, is that this feedback loop is critical, right? Is that getting this feedback loop. So that's one thing that I would recommend, is to think about the weekly demo is really truth serum. And in order to do that, you have to have something called continuous delivery set up, which we're gonna get into. And in particular, this is one of the most powerful ways to build something. Now, simultaneous to that, let me also recommend that I think that a simple ticket system still has some use. And let me show you what that would look like. I would recommend, even on a student project or a small company project, to use a very simple system for building things. And I would do Trello. So let's go here, Trello.com. And from here, I would go through and maybe make a new board, and we'll call this effective project management. Let's go through here. Let's just build something, effective project management. There we go. And what I would do is I would have only 3 columns. The simpler and the less things you have in a ticket system, the better. So I would say to do, make that lowercase. I would have in progress, and I would have done. And that's all you need. And more than that is overkill. And this represents 3 states. That means basically not yet. This means now. I'm working on it now. And this means done is self-explanatory. It's done. And if you keep things like this, you don't need to have emails, calls. In fact, one of the signs of a highly ineffective project management process, or even very disorganized or undisciplined person or project or company, is that they constantly want to have meetings. And if you constantly want to have meetings about stuff, it's because you have a bad process. But if you look at a board and you're doing demos, really it should be, instead of somebody tapping you on the shoulder and saying, "Hey, is it done yet?" It's like, build deployment system. And then you have a due date, and the due date is, I don't know, end of the week, right? We'll say it's Friday. Here's the due date. It's pretty simple. That's what I'm working on, and that's when it's due. Either you make it, and then you move it to the done, or you don't. And then if someone says, for example, "Hey, machine learning prediction," and that's due on let's say the 21st, like that, and then someone's like on Slack, blowing up your Slack, hey, is it done yet? Is it done yet? I don't know. Did you look at the Trello board? Last week we did a demo, and I demoed the deployment system. It's working, and we haven't started on that yet. In fact, it's not in progress. So you basically can eliminate a bunch of really ineffective processes by keeping a very, very simple Trello board and then mixing it with a demo. That's my experience. And then the one other thing that I would recommend potentially as well would be to use a Google Sheet. So if we go to Google Sheets here, and we just make a new Google Sheets. One other thing, if you're building like a quarterly or yearly plan for something, it's not horrible to at least maybe just brainstorm it a little bit and say, for example, just say like, Q4 2020, and maybe put the weeks in here, and you could say like week 1, week 2, week 3, and then you could, in fact, if we just grab this here and cut this and throw it there, and we could just say weeks, feature. That sometimes before you put this into the Trello system, sometimes it's not a bad idea to just say, okay, yeah, I think week 1, I'll do the back end, and then I'll do I don't know, front end, and then I'll do prediction or something like that. And then you can always refer back to this as you're building your Trello board out, so you don't blow it up with like 1,000 tickets. That's another way that I've seen projects have real problems, is someone just starts blowing up the Trello board with like 40 tickets. And it's like, wait a second, what does that tell me? All you did was make it so it's, now I don't know what's happening. There's so many tickets in the system. And so this seems like it's tangential to cloud computing, but all these things I mentioned here, which are effective technical communication, effective project management, demos, are in fact really critical to cloud computing. So now let's get into building stuff. So one of the other things that I want to bring up real quick is, in terms of cloud onboarding, is something called the DevOps Lifecycle. And so we're going to get into this on all three clouds. So what is the DevOps lifecycle? Really what it means is that GitHub is the source of truth, or whatever version control system you use. And it also has a build server. And in this case, the build server, we're going to use GitHub Actions. And in GitHub Actions, is going to listen to an event here. And this will be we'll have a 3 cloud environments. So we're going to have AWS, we're going to have Azure, and we're going to have GCP. We're going to do all 3 simultaneously, and they're all going to hook up and be able to make connections to GitHub. And then our code will be inside of this. It'll be the same code, same project. And what will happen is our code will be linted. It will be tested. And later, you can actually then deploy that automatically. And that will be called continuous delivery, is when you set that up. And that's what I have set up in a Flask project that I'll share later, that does continuous delivery on Azure. But the core concept is that these are robots. This is what Steve Jobs is talking about in his MIT lecture, is these are basically, I don't know what is a robot, like little things on their head, but these are basically robots that are constantly making sure all your code is working properly. And so this directly maps to the weekly demo, is that you have to have both. You have to have the automation and the robots watching things, and you also have to have the weekly demo. So let's now get into that. Let's start building some code here. So step 1, what I'm going to do is I'm going to say DevOps Lifecycle, make a new repo real quick, and we'll call this, actually, let's make it a fun name, and we'll say multi-cloud DevOps Lifecycle. That's kind of a fun name. Here we go. AWS plus Google plus Azure. We'll build all 3. And we'll initialize a Readme here. And we'll also add a Python ignore file here called Python. And we will create this repo. There we go. So here's our new DevOps Lifecycle repo. So that's step 1. And then in terms of step 2, I'm gonna start closing a bunch of these because there's too many windows open. I'm gonna close this, close this, close this, close this, close all these extra ones. And next up, I'm going to first get AWS running. So we'll go to AWS first, get that one spun up. I use a service in AWS called Cloud9. And Cloud9 is a cloud-based development environment. It works really well with free tier. So this works for any student. I'll show you how to create it real quick. You just say create environment, and we'll call this DevOps Lifecycle, like this, and just say this is a cloud environments for coding. And what's awesome about this environment is that it automatically times out after 30 minutes. It's free. I don't need anything special on my computer. It's all set up and ready to go, and it can make API calls on on my behalf without me having to manage API keys. So it's really a dream scenario for developing software on the AWS platform. So that's step one. We have AWS. Okay, now that only takes about 30 seconds to wake up. I'm also going to go to Google now. So let's go to Google Cloud. Let's go to GCP console. Now, GCP is a little bit easier. If you've created a free tier account, all you have to do is there'll be an icon here that has a little shell. And you just click Activate Cloud Shell. And I'll also show you a little Easter egg here that might be helpful, is that if you click on this link here, if you want to, you actually can change it to you can boost the performance. So you can say boost Cloud Shell performance. So just give this a second and I'll do that next. I guess I haven't used Cloud Shell in a bit, so it's taking a bit to unarchive it. Well, I'll boost it later. So we got AWS. Okay, there you go. And I'll say there we go. Boost Cloud Shell. So you can tell it to like get a little bit more power, like more memory, more CPU. Again, it's actually totally free as part of free tier. Next, I'm also going to go to Azure. So we'll get all three clouds working at the same time, and we'll go to Azure. Let's go to Azure portal. And we will go into here. I'm going to sign in. And here we go. Now, Azure is almost identical in terms of a copy to the Google Cloud. Look, you can see how identical these things are here. And if I click on this looks like it's working. Great. So now that I've got this set up, I've got AWS Cloud, I've got Google Cloud, and I've got Azure Cloud. And what I wanted to show you about all these is they're all pretty much the same. There's a lot of similarities. I'll make each of these a little bit bigger. And in fact, they work really well with what I'm going to do next. And so let me show you what I'm going to do next. Is I'm going to create a project scaffold. And this is something that I've developed over the last decade or so. And so we'll call this a Python project scaffold. So Python project scaffold. And so what is this? Well, step one would be that we're going to create the repo, which we did, and then we're going to create this structure inside. Well, we'll have a make file. We'll have a requirements file, which will be the Python packages. We will create a virtual environment. And also we will get some kind of local linting and testing working. Linting and testing. And we'll also go through here and get a build server set up. And that will be the GitHub Actions. And this is something I would say is, I will argue with any Python developer on planet Earth. I think I can win this argument. You should do this. They may do this in a different way themselves, but I think most people that are experienced would say, yeah, this is a good idea. You should do this. And there's really not a good reason to not do it. So let's go ahead and do this. So step one, and we can let's just pick AWS. They're the biggest market share. We'll start with AWS. The first thing that I would do would be I would create SSH keys so that I can link the SSH connection to GitHub so that we can do bidirectional communication. So I'll type in SSH keygen T RSA. So this is something you would find in the documentation for GitHub. Nothing too tricky about it. I just press return a bunch of times, and then it'll put this public file inside of this directory. So we'll say this. There we go. Next up, I will go back to my GitHub repo, and I'll go to my icon where my name is up here. And from here, I will go to settings, go to SSH and Gpg keys, make a new key. There we go. And I'll just say 88 keys because it's August 8th. There we go. Done. And once I do this, now I can do bidirectional communication from that particular Cloud Shell environment. So you need to do that for each of the Cloud Shell environments. I believe Azure and Google, I've already done that. But if you were going to repeat this, you'd have to do it yourself. So I'm going to go here and clone this. So I'll say git clone, and I'll put in the name of this repo. And by the way, you only need to do this once for each environment that you're developing. And since the AWS one is a new one I set up, this I do have to do it for the first time. And I will click on code and notice this toggling here. This is something that's really irritating you've probably dealt with, is make sure that you use SSH so you don't have to type in the password over and over again. So I'm going to copy this, go back to this environment and say git clone, paste it in here. There you go. So we got this clone set up here. And then what's awesome about this Cloud9 environment is, look, I've got these files here, and I've got this set up, and I could actually look at the README file if I wanted to, and I can even edit it and even make a change. So the next thing that I'm going to do is that I'm going to create a virtual environment, and then I'm going to create these scaffolding files and then check them in. So let's go ahead and do that. So first, I'll say Python 3-m venv. I like to call my virtual environments the same name as my repo and put them in my home directory with a dot so they're hidden. So I go like this. I say tilde/dot, and I say multi-cloud DevOps Lifecycle. And that way, if I always remember to create the repo as the same name as my virtual environment, I don't have to get confused. There we go. Source tilde multi-cloud DevOps Lifecycle and bin activate. So when you create a virtual environment, why am I doing this? A virtual environment isolates Python to a directory so you don't get package conflicts. And every time you install your software, you can just reference that one directory. So I can have multiple projects on my same machine. And then you would always source this directory. And if I type in which Python, there we go. We can see that this is actually located. So this is very, very useful. And I'm ready to go to the next step, which would be to create these empty files. So first up, I'll go and I'll touch a make file, and you'll see, there we go. And in fact, actually, let me move this make file. I want to move this into the multi-cloud directory. So I want to change it to multi-cloud, and I'm going to create these files inside of the Git repository. So we'll say make file. We'll also touch the requirements file here. There we go. We'll also touch the maybe like a hello file. That would be a good one to touch. And I think that's pretty good. We got basically enough to get started here. And then what I'll do is in the make file, this is where I would put it. Oh no, and then yeah, we got that. In the make file, what I would typically do is put these commands in. And so I have a scaffolding here that I will just copy from another project. If I go to PyTest, here we go, GitHub Actions, PyTest. This is a good one to copy from. Is I will just copy what's in this make file just to be lazy, and then I'll just change it. So this is typically what I do is once I've done this once, I don't need to do it again. But this is a key, really key point here, is these cloud editors, they forget to make files be tabs. And so you'll have lots of problems if you don't convert the makefile to tab format. So see, I changed it for here. You would want to do the same thing in other Cloud shells. So we'll go through here, we'll put this in. And now what I will do is just make this a little bit smaller, and we don't need the formatting. I can get that out. And hello, that looks great. And in fact, there's an install step. So each of these are commands. Later, if you want to extend this and do other things like do a deployment, you can just add a step here. But this makes it easy to kind of wrap these things together. And then the only other thing I would probably do is in the requirements file, because notice how it's going to install things from here. I would add in my packages that I'm going to install. So I would go through here and I would say pylint. Maybe I would also install click, which is a command line tool framework. And that's it. But right, just install a couple packages. That looks pretty good. Now I'm going to run make install, and it will install that software for me into my virtual environment. And why I like the make file is then I don't have to remember in the build server that I'm going to set up in a second. I don't have to remember anything. I just know that it works. And then if I want to add something really simple inside of here, like, prints hello, like this, I can actually do make lint here, make lint, and you can see my code is passing a lint. If I want to fail a lint, let's say I want to add a bad variable here. This is why you add linting, is it catches bugs for you. And so if I'd say make lint again, it catches a bug, right? So let's leave the bug in there for a second so I can fix it on another cloud platform. So I've got a good setup here. So now I'm going to check in these files. So I'm going to say get status, make file, hello, requirements file. Let's go ahead and say get add star, and that'll add all three. And if I say get status, you can see, there we go, make file, hello, requirements, those are green. I'm going to commit this, and when I do, it's going to have some warning messages that I'll show you how we can clean this up. So initial commit, there we go, and we'll say push. There we go, and I think this actually didn't give me those weird messages. Oh no, here we go. It did give me those. So I need to fix my username here. So I'll go ahead and do that. So we'll say this, and I'll put in my name so it knows who I am, like this. And then I'll do the next message here, which is my email address. Let's go ahead and fix that. Okay, we'll say get, and I'll put in my email. Perfect. And then the final message here that gives me is this. And this is just something that happens the first time you commit code on a new platform. I'm going to say Control O to write it, and then I'll exit Control X. There we go. And then I can do get push. I just do the up arrow, or actually get pull. So write it out. Exit. Yeah, get pull, and then do get push. There we go. All right, so this looks like it's good to go here. And if I refresh this, you can see that those files are in there, right? We got a make file, we got all this stuff in there. It's ready to go. So now let's test the same workflow out on the other cloud platform. So let's go to, let's pick Azure next, which is a little fancier than the Google one. It's nice black terminal here. So I'm going to do the same thing. I'm going to create a virtual environment. So I'm going to say Python 3 -m venv, and I'll say / dot multi-cloud DevOps Lifecycle. Let's just take this text here. There we go. Source it like this, bin activate. Great. Now we got the similar kind of setup here. You would have to set up SSH keys. I've already done this on this environment, so I'm not going to do it again. But if you haven't set it up, you would need to. And then I can just do a get pull. So I'm going to go here and go to code, copy this, and then do get pull. So here we go, get pull like that. There we go. Wait a second here. Git pull. Oh no, git clone. Sorry, git clone, not a git pull. So git clone. There we go. It clones it locally. I cd into this environment. Great. In fact, what's awesome is that this beautiful makefile type system makes all I have to do is one command. In fact, I just have to type in make lint. In fact, let me show you. In fact, all I have to do is run. If we look at the makefile, I can run. If I had set up tests, I could have ran make all, but we haven't set up tests yet. So I'll just say I'll run each command separately. So we'll say make install and make lint, and she'll install the software and then show it's broken. So let's see here. We installed all the software, and oops, it's broken, right? Which is really helpful that we have the lint so we can see that there's a problem. How do I edit my code in Azure environment? Do you see this icon here? This is how you open up the editor. And it's got a pretty decent editor because they make Visual Studio Code. They actually do a pretty good job at making an editor. There's that the project right here, multi-cloud project. If I collapse it or uncollapse it, I can go to the hello file and look, here's that bad variable. Let me just comment that out. Here we go. And now I can actually go through and I can fix it. So I can just say make lint. I fix my code. Now I can commit the change, say fixing bug found from lint. I need to actually add it first. We'll add it. Then I can do up arrow, commit it, push it. Great. Now this one pushes into the GitHub repo, and we're good to go. We got a change made 11 seconds ago, which was this is commented out. Now the code fixes. Now this is pretty good, but one of the things that we're not doing is we have to check all this code automatically, and this is something that we want the robots to do for us. So what I'm going to do next here is now do the same thing on the Google Cloud. And so what I will do here is I'm going to deactivate this shell because I had an automatic shell set up here, and I'm going to create a new one. So in fact, I'm going to be lazy, and I'm just going to go to history here. I'm going to look at my shell history and just copy the command because I don't like typing the same thing twice. There we go. Let's just type the same thing here. Now we're in Google Cloud. We make a new Python virtual environment. Now it's angry that it wants me to install this. Sure, we'll install this. So if you ever need to run something as the root user, you can always type in sudo space exclamation point. And what that means is run the last command as sudo. Okay. And there we go. So we're able to do that. And then I can do the same thing. I can again be super lazy, and I can just say, sure, let me do the same thing again. Which Python? There we go. We're in this directory. Also can be lazy and go to the other command here and then do git clone. Not the wrong command, the right command. There we go. Copy this. So you can see here, these cloud shells, once you get the hang of it, you really can do, they're very similar processes, and they all copy each other. So once you know one cloud, you start, it's almost like Portuguese, Italian, Spanish or something. It's like you kind of can start to get a feel for all these languages here. So I'm going to cd into multi-cloud here, and now I'm going to do the same thing. I'm just going to say make install the software, and then I'm going to say make lint, make sure that the linting works. There we go. and make lint. Okay, great, it works. So we now have all three environments. So I think the next iteration though is let's have the cloud, GitHub itself test our code automatically using something called GitHub Actions. So what we're gonna do is go to GitHub here, and there's something called Actions. I'm gonna click on Actions. And then let me just show you all the things you can do. Like you can deploy code automatically to Elastic Container Service. You can deploy to Google Kubernetes Engine. You can do all kinds of Tencent Kubernetes Engine, Terraform, just tons of stuff in here that's super powerful. But in this case, we're going to just keep it really simple to start with, but you can build on this yourself. And in fact, this may be the way you want to deploy software in the future to clouds. So I'm going to go and click on set up this workflow. And what it does is it creates this blank YAML file that has, really it's just like a recipe that says, when I push a change to the master branch, do something. And what we're going to do is we're going to actually tell it to do exactly what I was doing in the shell, but I'm going to do it inside of here. Now I do have an example of this already, so I'm just going to take a shortcut and copy it. And so here's this GitHub Actions PyTest. We'll go through here, and here we go. And I will go to raw and just copy this over. Now let's paste this into this example here, and let me just walk through what this actually does. So what this does is that it's going to use Python 3.8. I'm going to change this to Python 3.5 because Azure is the lowest common denominator and that it runs Python 3.5. So I'm going to make sure that our code works on Python 3.5. And then I'm going to do a make install, and I'm going to do a make lint, which is exactly what we're doing in the AWS cloud, the Azure cloud, and the Google cloud. So let's go ahead and do this. Let's go ahead and start this, and let's run this, and we'll say create GitHub Actions, commit this file here, perfect. And what will happen is this will automatically set up a trigger that will run this code. The first time you do this, it will trigger a Docker container that will run those commands, which are exactly the same commands I was running in the shell. In fact, these shells are also Docker containers. So we know it's going to have the same exact experience. So this is incredibly powerful process here, because now forever my code is going to have this feedback loop, and it's basically primed and ready to do later steps, which are add testing and also do continuous deployment. So what I like to do after I set up GitHub Actions is go to create status badge. So if you see this little icon here, there's like a fancy status badge, and I can just copy this and it will make a badge in my project. It's kind of like a, like a Boy Scout or Girl Scout badge. You just put it inside of here, and it does some cool stuff. Like, there we go, GitHub Actions badge. Here we go, adding badge. Okay, and then now if my code ever breaks, this will turn red, and I can click on it. It'll show me exactly what failed. So this is really, really awesome. Now the next thing that I would do here is let's actually, we have a little bit of time here. Let's build something a little bit more useful, which is what I'm going to build is a command line tool that would do something like talk to an API, which is a very similar kind of process. Let's say you're doing a job interview as a sales engineer, for example, and you wanted to build a command line tool that talked to the company you're interviewing with API. Well, this is what you do. So first up, I'm going to go back again to this cloud environment here. I'm going to log into it. Kind of kicked me out, so I need to log back in. Here we go. And I need to put in my auth code here. Go ahead and do that. Okay, so, and I'm going to go to this and DevOps Lifecycle. This looks like the one I was working in. So to add a command line tool, I will maybe make this a little bit smaller. It's a little bit too big. And also make this a little bit smaller, hopefully. It's good enough. And I will do a get pull. There we go. And now you can see that it actually commented it out. So let's actually make this do something halfway decent. So the first thing I would do is, in fact, I have some click command line tools here. I'm just going to copy to make things a little bit quicker. I'm sure in my GitHub somewhere I've got a command line tool in my 200 repos. Let's see, click. Probably DevOps. I think I have like a DevOps directory here that's got some good click stuff in here. Sure, this looks probably pretty good. Yeah, here we go. Hello, click. This looks like a good one. Okay, so I'm gonna just use this as a scaffold here, and I'm gonna go to this project and I'm just gonna paste this in. And let me just tell you what all this stuff does. So what I'm going to remove the stuff that's not necessary, and I'm going to make a function first that is like an API call, and it takes in a key, and it takes in a phrase or something like that. Let's say it's a like a Twilio or like some kind of a network type company that I'm interviewing with. And what I would do is I would return back maybe some kind of business logic. So we'll go through here and we'll say, add is equal to, and I'll make a phrase here, and the phrase will be %s is great %s, and then I'll put in these two words. So all it's going to do is just kind of put those two words into a string. So it's going to pretend like it's calling the API, but this is just like a pretend API call or something like that. And then I'll just return back, we'll just call this business logic like that. So it's just a string, but it could be a simulation for making some API call, and we'll just return this back. So it does basically nothing. And then we could actually put first, in fact, even I could comment all this out, and I think it's got that. I think it's got like a comment, toggle comment. And let me just make sure that we see how this works. So I'll say API, and I'll put in the word John. Or the key is 1, 2, 3, 4, and then the phrase would be John, right? And then we can even print it out, right? So this would be like a test of just a very basic function that I'm now going to turn into a command line tool. So we'll go through here, and we'll clear this screen up here, and we'll say Python hello. There we go. 1, 2, 3, 4 is great, John. Okay, some super simple phrase. So now what I'm going to do is I'm going to uncomment this and just use this as a template to call that function and be able to put parameters in there. So I'll go back here and toggle those comments, and we'll turn this into a command line tool. So we'll say first this will be API. So this will take the API key, and then this one will be the name. So this will be the name, or what did I call it? Phrase. We'll say phrase like this. And then all this stuff is just kind of extra stuff that it's just going to make the code too long. I'm just going to take it out. And then I'm going to take this out as well. This is just like prompts and help and all this stuff. Just to make things simple though, I don't want any of that. And then I'm going to put in the word, we'll just call this call API or something like that. and this would be API, and this would be phrase, like this. And then we could do the same thing. This would be like result, and it would be it would be this function here, which would be this would be actually key. This would be key, not API. So that's the key, and that's the phrase, and we would type in key here. And so we would use that function called API, and we would pass in the key, and we would pass in the phrase, like that. And then what we would do is that's it. That's literally all we would do. And in fact, we could just say print results, just like that. So it basically does almost nothing. Like this is like 10 lines of code. Now, this call API here, we want to fix this because it needs to be the same thing, like that. There you go. So this is like incredibly simple, basic command line tool that does almost nothing, except for it takes in a key, it takes in a phrase. We pretend like this is an API call to some like SMS system. All it does is print these strings together and it returns it back out. But this is very, very similar to like a very simple command line tool that a data engineer or data scientist or sales engineer would need to build. So let's go ahead and test it out. So what I would do is to test this out, I would type in Python hello -- help. Hopefully this works. Great. Look, it looks like it works. I could add fancier formatting and help all this, but we know it takes a key, a phrase. Okay, let's go ahead and do that. And I also can get rid of this here. We don't need this anymore because it's just kind of making things noisy. So let's run it again. Okay, we got help, great help menu here. So let's just test it out, make sure it works. Okay, Python hello, and we'll say it takes key would be, this is some special API key. That's my secret key. And then this would be the phrase would be I like APIs. There we go. There you go. So pretty powerful, really simple, got a command line tool. It works. So next up, let's say git status, add this, and we can commit this. So adding CLI, push it. Now that I've got an actual application, what I can do is write a unit test for it, and now I can put in the testing part. So I have a lint which looks for syntax, and I also can build a test. And the test is actually pretty straightforward. I would just type in test hello like this, and from here I would import this and use the click testing library. And I think in this repo I have an example of this. Let's see here, test. Yeah, there we go. So I'm just going to copy the same thing. I'm just going to copy this and just tweak it a little bit. So this is one big takeaway, hopefully, is that I like to reuse things that I've done in the past and just tweak them. And you can kind of get these recipe kits here. So this is the part that we'll use the click test runner, and then I'll just need to change this, and I'll say from hello, and I just need to import this call API function right here. So we'll say from hello, import call API function, and then I can just say test call API. And what's neat about this click test runner is it will invoke the command for me in a test, and then the PyTest framework will run this thing for me. So we'll say test call API like this. This looks good. And then all I need to do is write an effective test. So we know it takes a key, and then for the key we'll do 1, 2, 3, 4, and then we know it also takes a what did I call that again? I called it a phrase. So it takes a phrase, and then for phrase we'll call this Bob, and then it should return a positive exit code so it didn't fail, and we also should get the word Bob should appear in the output. There we go. So we got I think a good tests, except for this needs to be the same. It's right here. There we go. So invoke it and call it as it would be called from a command line. How do I test this? Our makefile already has this set up inside of here, so I can just say make test. And PyTest isn't installed, so I need to go back to my requirements file, which again, this is the power of this kind of scaffolding. I add in PyTest, and now I can do my magic make all command, because what does make all command do? It does an installation, it does a lint, and it does a test. So let's go ahead and do make all. There we go. Perfect. So it's all ready to go. And now if I go to my, if I do a git pull here, it should pull in the latest changes to make sure that's there. And remember, there's a Github Actions here. What I'm going to do is I'm going to add the final step, right? Which is I'm going to add in a make test step here. And go here. Test with PyTest. Make test. There we go. So now we've got install lint test. What is this called? There's a fancy buzzword for this, what we just created. It's called continuous integration. And it's the precursor to something that we're going to cover later, which is called continuous delivery, which is after you tested your code, you automatically deploy it and it's running in production. So next up here, let's go in and we'll say git status, add all this. So we'll say git add .github here. We'll git add requirements and look at, do we add everything? Oh yeah, we need to add the test file here. Okay, adding all code. Let's push this, and our continuous integration server, which is GitHub Actions, will now go through and run this. And if we click on Actions, the robot is sitting there waiting to do good things for us. It's sitting there. It's now running our code. We can click on it, and we're now in a great place because all the clouds that I'm working on have access to this code. Other people on my team have access to this code, and it's ready to do demos, to do continuous delivery. We're all set up. It's great. And if I go back to this thing, this particular repo is passing, right? And I can click on the link and it shows me that my badge is successful. And I don't know why it doesn't link back to the it just shows you the badge. It doesn't link to the actual GitHub Actions. But in a nutshell, this is continuous integration. It's ready to go. I can also now go to my other environments and then test this exact change. So I can say git pull, make all. And it installs, it lints, and it tests. I can go again to Google Cloud, do the same thing, git pull. There we go, make all. So we've got full end-to-end working on all three clouds simultaneously. Now, things are going to get a little bit different when we get into doing continuous delivery and things like that, but this is a pretty good place to just wrap up this lecture and just mention this, is that what you do when you set up something like this is the precursor to continuous delivery, but it's a very powerful concept called CI, or a CI pipeline. And a CI pipeline is essentially, it is a robot that is in there constantly testing your code and making sure that your code is tested, that it's linted, and that it's practicing this concept of Kaizen, right? And so really, really powerful concept that I will argue any person on earth that if they tell me they should not do what I just showed, I'm fairly certain I can win this debate, because there's no valid argument. Why would you not automatically have your code tested and linted, right? Now the deployment, I could see that's a more gray area, but this is something that's so useful and so good. Every project in Python should do exactly what we went over. All right, so let's maybe stop there. The timing is pretty good, and see